Hello, everyone. Me and Ashtoush will present hybrid cloud orchestration for telco workloads. I'm Varprasad Talari, Principal Consultant, 5G NFE, Industry Specialist with AWS Telco ProServe.
Hi, I'm Ashtoush Tulsi. I'm a senior solution architect focusing on end-to-end 5G mobility, working in the AWS Telco go-to-market. Very nice to meet all of you.
Next slide. So we want to start the presentation with the telco customer landscape, and then we'll talk about hybrid cloud with AWS. Then we'll go into hybrid cloud telco automation and hybrid cloud telco orchestration. Next slide. Next slide. So while we talk about the telco cloud landscape, we want to look into why there is a hybrid cloud infrastructure need for telco cloud, right? Why offer its solution at all? And what we normally see is the CSPs, the communication service provider, will operate in hybrid mode for years to come with their existing hardware footprint. They have a huge hardware footprint that they will continue to maintain. And as they move towards the cloud, there will be a hybrid architecture that will be there for many years. And also, the latency is very important because when you're enabling use cases, the speed of light cannot be beaten. So you want to bring the workloads closer to the edge, and you provide the latency that is required for many 5G use cases and the bandwidth itself. Also, what we are looking at is, to have analytics at the edge. It's necessary to power many use cases because with the analytics on the edge, you can provide the intelligence that can feed into the orchestration and higher levels that can generate and create a lot of ultra reliable low latency use cases, massive mission type communication, enhanced mobile broadband use cases. It'll unlock a whole range of 5G use cases, right? And then we want to offer a rugged solution from AWS at the edge because we are looking at the survivability of the system at the remote sites, and that is the key to enabling all these use cases. And if you roll back and look at why we are looking at hybrid infrastructure is we see that the operators will be in hybrid mode for many years to come. Latency is important. Speed of light cannot be beaten. And with the analytics at the edge, we can power all the 5G use cases, and the survivability of the system at remote sites is key. So we wanted to address all of this. Next slide. If you look at the telco transformation with AWS, we are looking at four major pillars. And one of the pillars is network Cloudify, where we are orchestrating a secure, scalable, software-driven network. Growth Unlocked, where we are accelerating innovation to monetize 5G, edge, and enterprise transformation. Operations Simplified, we are transforming and automating for the future of the business. And Customer Experience Reimagined, where we ignite your data to predict and personalize every interaction with AI/ML. Today, we'll look at the network Cloudify, where we're looking at how we can orchestrate a secure, scalable, software-driven network. And more importantly, we'll focus on the hybrid cloud itself and hybrid cloud orchestration. Next slide, Ashtoush. And what are the customer challenges we see? We see there is a governance challenge, there is a regulatory data residency requirement. We see the complexity of operating Kubernetes across on-premises and cloud. And operators are looking to reduce cost and have open source software is not secure and not up to date. So how do we address these challenges? And all these challenges, we will address them as me and Ashtoush will go through the hybrid architecture that AWS put together. and how we bring in automation, how we bring in orchestration to address all of these customer challenges. And we'll take you through this journey as we are going, as we are speaking in the next hour or so. Uh, Slide, Ashtoush.
All right. Thank you, everybody. And thank you, Vara, for that introduction. So, in this section, what I wanted to cover were two aspects of hybrid cloud. One is the infrastructure part of it, which AWS offers, and the second, a very important thing when we are going to talk about telco workloads now is in terms of the cloud native software, right? I mean, uh, granted that VNFs are still going to be there for some time, but as the standards evolve and as the 4G and the 5G network functions evolve to CNF, one of the key area for operating these telco workloads will be the container piece, also the container orchestration. So in this section, we'll be covering two parts of it. One is the underlying infrastructure, and the second is the Kubernetes aspect of it. So if I may put in this slide, I've captured in one go both the parts of it. So the availability zones, local zone, outpost, wavelength, and snow family is part of the infrastructure piece, and then there is EKS and EKS anywhere. So if you look at the infrastructure that AWS offers, our goal has always been to provide what the customers and the workload requirements are to enable an infrastructure that can support all these different kinds of workloads, because each workload has different attributes, different latency requirements, different throughput requirements, and different compute storage and database requirements. With that being said, let's start from the leftmost piece, which is the availability zones. So AWS has regions around the globe, and each region has at least two availability zones, and each availability zone itself comprises of a redundant infrastructure, and these availability zones are within a region are spread across 60 miles or almost close to 100 kilometers. So they are geographically diverse set of availability zones on which you can deploy the workload. The primary use case of availability zones or the regions in terms of hosting the workload, if I may say, is more like OSS, BSS, your control planes, and your analytics applications or the analytics machine learning algorithms themselves. So those are the kind of workloads that you can have on the availability zones. The second type of infrastructure that AWS started offering recently are the local zones. So what we saw was there were a significant number of workloads which require lower latency, and just because if they are farther away from the region, then the workloads will not be able to satisfy the requirements of the end user. So from that perspective, we started offering local zones, and these are also a managed infrastructure by AWS, akin to the availability zones, and they have compute, storage, database, and a select few services that are available in the region. But the key attribute of local zones is they are closer to large population of metro centers or large industrial areas. And so the use cases we are seeing from a telco perspective are like user plane functions, or even a lot of gaming applications, and the workloads such as which require AR and VR. Those kind of are the workloads that we are seeing getting deployed on the local zones. The third type of infrastructure which we have developed and offered to our CSPs is running workload in their premises. And so this typically align with the kind of workloads which require low latency and very high throughput. So from that perspective, they can run it locally in their own data centers. Also, we are seeing for some CSPs, data residency requirements are a regulatory mandate. So from their perspective, also it makes sense to have something like an outpost running in their premises. And a couple of workloads that come to mind from a telco perspective are like the user plane function or the CU of a RAN function, and perhaps a DU also at the far edge of it, because outpost comes with currently is available with one form factor of 42U, and very soon we are going to have two other form factors of 1U and 2U, which will be, or which will enable workloads such as DU to be run on those outposts. The fourth one is the wavelength. Now, this is a unique kind of offering in which what we realized when we talked to CSPs was CSPs are deploying their 5G networks, and they would like to enable developers out there who want to utilize this 5G network for developing unique applications, and they would like to host these applications very close to the 5G network itself so that they can benefit from the low latency which is being made available, or for ultra reliable low latency applications. So from that perspective, CSPs collaborate with AWS, and what we do is we provide them a complete managed infrastructure, but it sits inside the data center of a CSP. So the 5G network and the data centers are on the wavelength are very close to each other. Thereby, you can have the best of both the worlds in terms of a IT kind of a development environment very close to your 5G network. So that is something which we are collaborated with multiple CSPs as of date. And the last infrastructure family that I wanted to talk with regards to this was the Snow family. This is a kind of an infrastructure which is a little different from the first four. The first four are kind of always connected on the AWS backbone, but Snow family is from the perspective of serving the needs of more of a infrastructure that is required to host workload that may not have constant connectivity with the AWS region. So there can be intermittent connectivity. So for example, private or cruise ship, or in the industry, in the manufacturing plant, or those kind of places. And we have also seen a lot of our ISV partners and the partner ecosystem have run a complete private network on this device family of devices. So these were the five types of infrastructure on that AWS makes available to run every and all kind of telecom workload on this, whether it's in the region which is sitting in the AWS data centers, or local zones, which is again a managed infrastructure by AWS, an outpost which can be in the CSP's data center, and Snow family, which is much more of in a ruggedized environment. And the last point I wanted to talk to you was about the EKS Anywhere. So this is a recent offering, and what the difference between the this and the other offering, Kubernetes offering, that I'll just speak about, is that this can run on a customer owned infrastructure. So that is the fundamental difference. And the on the first four, you can have what we call as the elastic Kubernetes service, which runs in the region, the control plane of it, and the compute nodes or the data plane nodes for that Kubernetes cluster can run in local zone or in outpost or in wavelength. So combined with the combination of EKS and EKS Anywhere, primarily you can handle any kind of CNF, whether you want to run it in the region or in the local zone or outpost, with the control plane being in the region, or for EKS Anywhere, wherein you can deploy the control plane and the compute nodes or the data plane nodes in your own infrastructure on your own servers. So that was about the infrastructure and the Kubernetes enabling you to have your infrastructure and the container orchestration across the locations. And just to summarize it in terms of pictorial form, I have got a picture here of cloud continuum, what we call as the cloud continuum, wherein you have infrastructure in the region or on premises or in the far edge. And the fundamental thing that I wanted to point out here was the same AWS experience, a ubiquitous programming model using which you can have or manage the infrastructure, whether it's in the region or it is on your premises or it's in the far edge. And this is what the 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 goal is for AWS, so that CSPs, whenever you want to run your workloads or wherever you want to run your workloads, you can run it in the most appropriate location. And of course, needless to say that this AWS infrastructure, like for example, availability zone and local zones and wavelength, they're connected over the AWS high-speed backbone. And then there is another option in which for your outposts that are in your data center, you can either connect it using a direct connect service, which is relying on having dedicated physical circuit connectivity, or you can also use the site-to-site VPN. But from a telco workloads perspective, of course, it makes more sense to have a direct connect kind of a dedicated connectivity available so that the telco workloads can be run for services such as data sessions and voice sessions and services like IMS and so on and so forth. On the rightmost part of it, what we have also shown is the EKS anywhere and the outpost 1U 2U. So depending on what the needs of the CSPs are, you could run your DU workloads on the outpost 1U and your CU workloads on the outpost 2U, and so on and so forth. So this is the cloud continuum, and the underlying benefit being for this cloud continuum is the same AWS experience, similar APIs. So single pane of glass for observability, and as we'll cover in the next part of the section, single pane of deployment across this infrastructure location, multiple infrastructure locations. The second piece, what I wanted to cover in this was about the different EKS options that the Elastic Kubernetes Service that AWS offers. Primarily, there are two. One is the EKS, which runs in the region, and the worker nodes or the compute nodes running in either the region or availability zone or local zone and outpost. And the second is EKS Anywhere, which is going to run in the customer data centers. So the difference being, in the EKS Anywhere, it's your hardware, but it is the same consistent tooling that is offered in the EKS, which is going to run in the region. And from a manageability perspective, as you go down, the EKS Anywhere, there is some amount of management that is expected of the customer. However, the tooling is going to be provided by AWS. And the EKS distro, again, it's a completely open source. So EKS distro and EKS Anywhere are similar in terms of the software bundling. But from the perspective of differences, EKS Anywhere is supported, but EKS distro is just for from the perspective it's an open source software. And of course the EKS and running in the region with the compute nodes in availability zone, local zones, that is something which is completely managed by AWS. So if you want to run a workload on a Kubernetes cluster without worrying about the scaling of the, say, the control plane of the EKS, then that is one option to look at, because that enables you to not be worried about what do I do, how do I manage my control plane for my Kubernetes. It's a completely managed control plane offering. Uh, Again, looking at what the deployment looks like for the CNFs using AWS Kubernetes, the EKS on AWS, which is running in the region, is a fully managed control plane, which has its own auto scale mechanism enabled in it. So you can go start with minimum number of nodes to thousands of compute nodes without worrying about how are you going to scale your primary control plane instances, right, or primary control plane capacity. So all of that is taken care under the hood by AWS, and it's a completely managed offering. Whereas the EKS Anywhere, AWS will give you the tools to deploy, upgrade, and operate, and the whole thing is available, and we will see it in the next slide as part of a single observability console. So the underlying infrastructure and orchestration for the EKS part of it is managed by AWS. Of course, the control plane is highly available. Basically, all of us in the telecom vertical or the functioning in a telco business are aware of the high availability requirement. So that is something which is absolutely fundamental to this EKS service. And then the other part which I wanted to talk to you was about, by utilizing this managed EKS from within the Kubernetes itself, you can utilize the services, other services like CloudWatch and Container Insights and so on from within the Kubernetes environment. Of course, I mean, if you guys are interested, we can have a separate conversation after this session is over about what kind of different tools are available to make the the Kubernetes cluster more secure. For example, how can you utilize the identity access management and so on, and the observability piece of it, the CloudWatch and so on, with by using the Elastic Kubernetes service and the EKS Anywhere that AWS offers. Just to touch base upon the operational experience across on-premises and cloud, as you can see, the EKS Anywhere and Distro and EKS are two separate offerings, but they are visible from one single EKS console. So if you have hundreds of clusters that are spread across multiple locations on the different kind of infrastructure that either AWS offers or your own infrastructure, you can view all of them through a single EKS console. There are deployment tools that are made available using which you can have a single pane of deployment, observability, and of course, you can set up policies which will enable to run a way better and a secure Kubernetes clusters across the different locations. The EKS Anywhere, you can have it on premise running on in a VMware VM environment or bare metal, which is going to be coming pretty soon. And the EKS you run on the AWS infrastructure, whether it's in the availability zones or EC2 instances. And that's what I wanted to cover in terms of the cloudification of the network and how AWS, what kind of services AWS is offering in terms of infrastructure and the Kubernetes layer. What up to you?
Yeah, thanks, Ashtoush. As Ashtoush mentioned about the hybrid cloud offering from AWS, now I'll take you through the hybrid cloud automation for telco workloads. We'll talk about how we are enabling the same CI/CD from region to edge, and how we can use the tooling and services that are available for AWS cloud from region to edge. Next slide, Ashtoush. And before we get into the details, working backwards, we would like to see what customers are looking at, right? They're looking at the consistency of experience and operations. So they would like to have the same reliable, secure, high performance infrastructure, both at region as well as edge, same operational consistency, same services and APIs, same tools and automations, deployments and security controls, same pace of innovation, both in the region as well as in the edge, and basically running one network with NFs, with network functions and telco workloads across regions, local zones, wavelet zones, and outposts. And Ashtoush talked about them in the earlier section. So next slide. And I'd like to start by just giving a brief run through of some of the cloud automations that we developed for 5G on AWS. Right. The fundamental pillar of the cloud automation for 5G in AWS is our AWS CI/CD. We have developed a full end-to-end CI/CD for 5G network deployment and LCM through our CI/CD code pipelines, both for infrastructure as well as for application, the network functions. And building on top of CI/CD, we have enabled observability, right? We integrated some of the native tools like AWS CloudWatch and CloudTrail, and with Prometheus and Fluentd to enable the full observability. And building on this pillar of observability, we have developed a lot of closed loop automations. The closed loop automations, we have achieved them by integrating the infrastructure logs, the CNF logs, the assurance platform, and all of them interworking through an API integration. And building on this closed loop automation, we have extended it further to enable network slicing for a 5G network on AWS. So for this, what we did was we integrated an orchestrator with AWS CI/CD pipeline to enable network slicing. And as we talked throughout this last many minutes, is we extended all these automations from region to edge with our hybrid cloud deployment. It's the same pipelines to deploy the CNFs for all target environments, whether it's region, edge, or on-prem. And we have seen that one of the, and as we talked in the telco landscape slides, the edge analytics is one of the key enabler of 5G use cases. So we have developed an inference at edge using AWS EMR. And we started enabling AI ML into our analytics. And we developed predictive automations like forecast-based scaling, predictive maintenance, and many others. And one of the things that we have seen while we are working with CSPs is this long pole in the tent is this testing as a service. It takes many weeks to complete the testing. So we have automated the whole testing itself, and we framed what we call test as a service. Where we have enabled a zero-touch automated 5G testing with our full CI/CD integration. So directly from the pipeline, the services will be invoked, and you can run the test in a matter of minutes rather than taking weeks. And we are building on this cloud automation, and we are integrating other CNCF projects as we speak, and we are bringing in the full power of AWS services to seamlessly enable 5G and 5G use cases. Next slide, Ashtoush. So, as we talked in the previous slide, the key pillar for our automation is AWS CI/CD, and this is we are taking from the modern software delivery methods that we have employed in AWS for many years and applied it to NFV, to telco NFV. And I'm just showing you some of the tools what we have developed. We are using as part of this CI/CD pipeline is we are authoring it using AWS Cloud9 and AWS IDE toolkits. And the source we are using AWS Code Commit, and we are doing the CI in AWS Code Build and testing that we talked in previous slide. We are using both AWS Code Build and third-party testing tools, and we're deploying through AWS Code Deploy, and with Monitor we have AWS CloudWatch, CloudTrail, and X-Ray, and others, right? And all of this is stitched by AWS Code Pipeline, and it is put together and it orchestrates the pipeline itself. Now, if I look in the bottom, we are building NFs, and then we are deploy by network vendors, and then we are deploying NFs on AWS infrastructure, and we are able to enable the operations in the telco network. Next slide, Ashtoush. So I just want to take a minute and walk you through the whole CI/CD pipeline. And this is a high-level picture, but it will give you a gist of what we have built and how our pipeline works, right? At the beginning, and it has multiple stages that we call day -1, day 0, and day 1. At day -1, we are setting up networks, the VPCs, the subnets, the ACLs, and other network prerequisite, and that we call day -1. And in day -1 also, we have enabled all of these through service catalog automation. So the whole day -1 is completely deployed to automation. And as the day -1, the network prerequisites are deployed, we get to the next stage, which is day 0, where we install the infrastructure, which is basically the Kubernetes clusters, the node groups, the storage, the utilities. And here we have created some innovation. So what we started doing is we have seen that all the pipelines have common components that they need for at the infrastructure level. For example, every CNF would need a node group, a storage, a utilities, and different CNIs. So we developed what we call reusable common construct. Think of it like a shopping cart. So based on the CNF's requirement, we can define CNF user config file, and then we can select the different components that are needed for this particular CNF at the infrastructure layer, and that will build a pipeline with less than 10 lines of code, and the infrastructure will be deployed. And as the infrastructure is deployed, then what we have often seen is that when we go to deploy the network functions, there is some infrastructure issue that is preventing the CNF to be deployed. So we introduced after the CNF after the infrastructure is deployed, is installed, we introduced a network infrastructure validation, which is you see that arrow going to the test automation. So it validates the infrastructure as per the CNF's requirement, whether everything has been properly deployed and properly configured at the infrastructure level. Once that passes, then it will go to the day one, which is installing the network function. Here we introduce another thing as well. As the infrastructure is deployed in day zero, all the endpoints of the node groups, the storage, the utilities are stored in a common SSM parameter store, system parameter store. And when it comes to day one, when the pipeline is about to deploy the network function, by calling the CNF Helm chart, it goes and picks up the infrastructure endpoints from the system parameter store. Now, how the application pipeline will know that this is the particular infrastructure component that I need to include to deploy the CNF is we have introduced tags. So based on the tags, each of the each of the infrastructure components that is deployed will have a tag. For example, a node group will have a tag called AMF, AMF-1 if it is an AMF network function. Based on the tag, the network function will go and pull that infrastructure endpoint and uses that, and then runs the Helm chart and then deploys the CNF. And all this is happening through automation dynamically. Once the CNF is deployed, if there is a new Helm chart or a new image, then you can run a continuous update in a similar fashion. So earlier I talked about after the infrastructure is deployed that we do an infrastructure validation. After the CNF is deployed, now we integrated the pipeline with the REST API to a testing automation platform that will go and call for what are the available tests that are there in the test automation platform, and then comes to the pipeline, and then the pipe and the code will check which particular network function it is, which particular test it needs to run, and and then with the payload it goes and runs those tests. And once the result is available, that result is sent back to the pipeline. Then the pipeline can push it to production automatically, or you can put an optional manual approval with the result. And all of this is completely through automation and runs seamlessly. By doing this, we have another interesting development we have is that you can build multiple environments, and because you're running the same pipeline, and you can deploy it in multiple environments, and you can have multiple stages of the CNFs. Different versions of the CNFs, and you can either send them to approval for production, or you can stop them at your test environments. All of this CNF deployment and update time reduced from days to minutes. And I'll talk about some of those numbers in the next few slides. But personally, I know in the past, in the traditional telco, we used to take many weeks to deploy, and now we're talking about minutes using this powerful CI/CD pipeline that AWS brings in. Ashtoush, next slide. So here are the AWS CI/CD differentiators observed during development, and so in day zero, where we talked about the cloud infrastructure deployment, we're averaging around 20 minutes. And in deploying CNF, we are looking at around 15 minutes, an update around 5 minutes. And this is like a mid-sized major network function that we have counted and we have timed it as we've done all these CI/CD pipelines and deployed them many times. And then you have a pre-integrated test suite for rapid testing on demand and in a continuous fashion. These average times actual may vary from the actual times, but this is an average that we have seen with the real network function with one of the major CSP with one of the major ISP vendors. On an average, we have seen 80% reduction of CNF deployment and updates when compared with traditional deployments, days to minutes. Yeah, and that is we have measured it many times. Next slide, Ashtoush. So I just want to take a bit of a minute and talk about the testing as a service that we talked in the previous slide when I was talking the overall CI/CD. So often what we have seen is in traditional telco deployments, we have seen the deployment itself will take around 1 to 2 weeks, and then you have 2 weeks of testing. And we wanted to address this holistically as to how we can bring automation and how we can address the time to market for the CSP operators. So we have developed what we call testing as a service. The testing as a service is integrated into CI/CD pipelines. It will completely accelerate the CSP's testing and validation cycles. The testing is triggered and executed every time there is a new code pushed or a new CNF is deployed. And there's a rapid discovery and isolation of the faults, ability to include new tests, platforms without change to CI/CD pipeline because it's only an API integration for us. So let's briefly run through how this will happen. If you can see on the left-hand side where we have the pipeline itself will invoke with an API to an API gateway to get the number of the available tests. And then that passes through Lambda and talks to the ISV testing automation platform and then gets all the tests. And once the tests are returned to the gateway to the Lambda, it inferences and it matches with the current CNF that is deployed, and then it'll select a certain set of tests. For example, if it's an AMF, then it'll pick up an AMF test bundle, and then it also gives in the payload that this AMF or the CNF that is currently just deployed. It gives the endpoints of the different interfaces like N2 and N3 so that the test automation platform can dynamically configure and run those tests. So that payload is passed to the Lambda, it goes to the ISV test automation tool, runs the test, and then there is an API gateway where it is collecting where it is updating the test progress. That is goes through the SNS for any notification. And through Lambda, it passes in two ways. One is through a DynamoDB, and other through the observability framework that goes to the dashboards like Kibana and others, and it's collected through the CloudWatch. The one input from that Lambda that you see in the right that is sent to the DynamoDB that keeps the upkeep of the current test progress and if the test is passed or failed, and that is fed to the Lambda function that you see on the left that goes back to the pipeline. And then once the test is completed, this DynamoDB will update the Lambda function on the left and updates that goes through the gateway and passes through the pipeline to either go to production or to kick back the software back to the ISV vendor. So this tremendously reduced the whole testing cycle, and we are not talking 2 weeks, we are not talking a week, we're talking about a couple of hours and most likely within a day. And as we build these more bundles, you can completely accelerate the whole CNF deployment and testing cycle. Next slide, Ashtoush. I want to briefly talk about the network observability. And as we seen the network, as we seen in the previous slide, when I talked about the cloud automation for 5G, one of the next things that we developed as part of the automation was to enable network observability. So the CSPs are leveraging CloudWatch to track the performance metrics of the 5G core. In addition to cloud infrastructure, the CloudWatch monitors the CNF and VNF system-wide performance changes and provide the unified view of the operation health. And the data from the observability is actually used to trigger any kind of higher level operations through by integrating the triggers to the orchestrator, like scaling, healing, replay. Replacement, placement of the network function, and so on, right? Or even the reconfig. So, in addition, using the data mesh, we are enabling batch processing, real-time processing, and forensic use cases that are needed with the data platform. At the heart of it, you see that, as you see in the picture, as the CNF is deployed, using the common construct, we are deploying the utilities like Fluentd and Prometheus, and then we are feeding those, the logs and the metrics that come from those to a common AWS Elasticsearch where you can run reports and get intelligence out of it. Additionally, we are and another point that I like to mention is there are three things that are going here. One is the application logs, another is the infrastructure logs, and the third is the test logs. And then we are also feeding them to a Grafana dashboard, and also we have the CloudWatch dashboard where you can create additional alerts, alarms, and then pass them to the AWS simple notification service, and then send an email or an SMS. So uh, bottom line, we have addressed the whole CI/CD process and how we can deploy the application, both the infrastructure as well as the application, address the automation of the network prerequisite, and then we address the need for rapid continuous testing, and we have enabled network observability to enable higher level use cases. At this point, I want to say that this same pipeline, the same testing automation that you're seeing, the same network observability that you're seeing, extends from region to edge. Because for us, it is just another subnet as to where we are running, whether it's in region or in edge, and it runs seamlessly. The whole automation would run seamlessly from region to edge. For example, some of the average times I talked about, we calculated them also in the AWS Outpost and in our edge clouds, and we are seeing the same rapid deployments using bringing it to minutes instead of days. Next slide, Ashtoush. So while I did talk about the CNF deployment, the testing as a service, the observability, Ashutosh earlier talked about the Amazon EKS Anywhere. We can deploy EKS on bare metal or in VMs. So we have, if you look closely here, the first bubble that you see, the 5G CI/CD on AWS, is the same CI/CD, whether it's in region or edge or in outpost or in anything else. We are enabling the same thing. But we have also introduced as to how to deploy the EKS anywhere itself on a bare metal or a VM. And what we have done is we have started creating packages like what would be the CSP's golden configuration customization, what sort of logging they want, what sort of monitoring they want, what sort of security customization they want, the CNI and the network design storage integration, and so on. And then we have created what we call the CSP configuration package, where we are first deploying the EKS anywhere, and then we are enabling this golden config. And after that, the CI/CD pipeline would come in and deploy the CNF itself. So it was going really quick and massively, and we are using the same automation. Next slide, Ashutosh. So I just briefly talked about the whole hybrid cloud automation, and now I'll be talking about the orchestration itself. And if you look at AWS services and how ETSI NFV framework, MANO framework will sit in, using here is the using the ETSI GSNF MAN 001 reference. We look at where you can see the CNF, the VNF manager, the VNFM, and the VIM, which is the virtual infrastructure manager. That all of that we enable through our pipeline, and I'll talk about it how we are enabling the integration to NFVO, and of course the NFVI. We are providing the infrastructure for the virtual workloads where the CNF that you see in the blue will come from the ISVs that could be deployed. And how we are able to do all of that is what you see on the right-hand side, where we have AWS native services that we can simply call and we can enable all this orchestration. Next slide, Astosh. So the MANO on AWS deployment models, we are looking at three models. One is where we are using AWS native tools and we can enable the MANO with AWS services. The second model, what we are looking at is to deploy a third-party orchestrator like ONAP, open source MANO, or Ericsson's orchestrator, or Cloudify, or any other third-party orchestrator. And we can simply integrate the orchestrator with our pipeline, and which we'll talk about it in a minute. The third model where we're talking about is orchestration integration with AWS, where the third-party orchestrator is sitting in CSP's its own private data center, and we can simply integrate it because it's all an API call. We can simply integrate it and we can enable the orchestration. So if you look at the three models, we're looking at one using AWS native tools, another is hosting an orchestrator on AWS, and third is integrating the orchestrator with AWS. Yeah. Next slide, Astosh. So how are we integrating the orchestrator with AWS CI/CD pipeline? And here is a small picture that I'm showing you at a high level how we do this integration. At the left-hand side, you can take any third-party orchestrator. The first thing we do is we enabled a token-based authentication. So the orchestrator would talk to an AWS Cognito, will do a token, will get a token, and then there's a token return, and using the token it'll invoke an API with our API gateway. The API gateway will then go talk to the Cognito, and then gets and validates the return token validity and validates the access token. Once it is validated, the API is sent back. The API call is then sent to a Lambda function. So here is where the magic happens. So we get an API calls in the SOL3 format, right? It could be for instantiating the CNF. It could be to inquire a CNF. It could be to scale a CNF. We match each of that API to a particular Lambda function, and that Lambda function will in turn match to a pipeline. So as we are sending this API call to the Lambda function, we have a payload with it. And in that payload, as I talked earlier, we'll talk about we'll talk about what this orchestrator would like to deploy, right? For example, or what the orchestrator would like to do from an LCM action point of view, whether it is scale, whether it is placement or anything. So in that payload, it will contain like all the CNF details, like what package that it needs to deploy, what is the CNF you're trying to do the LCM, and what is the location, in this case being the subnet. And based on that, the Lambda will then first check with the IAM rule whether this particular action has approval, and based on that, it'll go to it'll and the user, this orchestrator user, has that approval, and then this Lambda will map it to a CI/CD pipeline, and then the CI/CD within the CI/CD pipeline, it'll go to the code build. Then the code will look at all these parameters and it'll say, great, and then I need to deploy this network function, or great, I need to scale this network function, or great, I need to place this network function at a different life cycle that is defined in Sol 3 interface. And then the code build will now do the CI, get the artifacts from the code commit, and then it'll go and create that EKS clusters and worker node groups, and then proceeds to deploy the application. And as all this is happening, all these logs from code build and Lambda are sent to CloudWatch, so you can see what is happening with the progress. Also, what will happen is, as the Lambda is invoking the code build, it sends the return result back to the API gateway. Then the API gateway will send it back to the orchestrator. So the orchestrator will know that its API call that it sent out actually did happen, and it's progressing. And then the progress you can see through the CloudWatch. This whole integration is done by AWS, and we have enabled the seamless integration of an ETSI MANO NFVO orchestrator into the CI/CD pipeline, and we enable the full orchestration. And again, for us, when we are talking about an edge location, it is the same pipeline, same integration for us. The only thing it changes is the payload, where instead of going to a subnet in the region, it will go to will go to a subnet that is in the edge, and that is how this is seamlessly happens in this hybrid cloud architecture. Next slide, Ashtoush. So often there was a question about I mean, this is great that you have integrated the Sol 3 and NFVO with VNFM or CNFM. And then how about the config? How about the SMO functionality that VRAN brings in, especially with the Open RAN? And this is where we address that as well. And as you see, the NFVO to CNFM is the same Sol 3 integration that you can see, and the CNFM will integrate to the pipeline. The CNFM I talked in the previous slide, and it'll go and deploy the VCU, CU, CP, and CU UP, and also parallelly it can also deploy it on EKS anywhere on CNF VDU as well. So now these two actions about the CU instantiation or DU instantiation, that is starting from what in Open RAN, from the RAN SMO or domain manager, where it can initiate a certain network function deployment and a placement of it, and NFVO can take that API call, pass it through the CNFM, and the pipelines will activate and will deploy. As and when these CNFs are deployed, we have built a local inventory using DynamoDB with our CI/CD pipeline. So it will keep an inventory of what has been deployed, and those are sent to that local inventory. This local inventory will now update the federated inventory, where the federated inventory has the whole structure of the whole. Network that is deployed. And you see that the SO, before I go to SO, but you can see that the CI/CD pipelines and NFVO are still using the same AWS repo, code commit, and ECR. The DNS is the common DNS that we have through our Route 53, and it can use it. And I also put an EMR. If you see on the right hand bottom, that EMR is what is enabling the edge analytics that you can use it, right? So as we are deploying these radio network function, the VCU, CP, and CUCP, and VDU, the config and the config itself, of course, this SMO slash RAN domain manager can query the network functions through NFVO to the inventory and get the status update to it, and it'll know that it can get information about what is currently being deployed and so on. But let's say if they wants to do a config update, the config update can directly be sent from this RAN SMO onto the CNFs that you see there in the arrow that you can see it going towards the VDU as well as the VCU. Now, the whole call home functionality again enabled through the standard interfaces of Open RAN, and you can and there is a policy. You can enable a certain policy as to how the VDU needs to react, and if you have non-real-time rig function, you can enable a number of apps like looking at the current config. If you want to enforce a certain config into the RAN components, you can enforce certain config and enable the apps that are sitting on top of non-real-time rig, and enable the rig apps and enable all the use cases right at your RAN SMO and connecting to your RAN SMO. So this whole RAN LCM and config is thought through, and I want to bring two things here. One is on the right-hand side, you're seeing an EKS, and here I'm showing you VCU, VCP, CUCP, and CUP. And this could be, for example, local zones and outposts that Ashtoush talked about. And then if you see VDU, it is EKS and EKS anywhere. So it could be the EKS anywhere, which sits on a VM or in a bare metal hardware where you can enable the whole EKS to deploy the VDU. And what is interesting that you need to see is the same pipeline that goes through this local zone for CUCP and CUP is the same pipeline that goes through the EKS anywhere for VDU. And all of them are seamlessly integrating with NFVO and then seamlessly integrating with service management SOM, and then seamlessly integrating with the RAN SMO and enabling all the call homing, the config, and the recaps, and all of them nicely comes together and completely gives you a full hybrid cloud orchestration that you need for a 5G or a telco network. Now we want to summarize few things, right? One is the telco network need infrastructure to run workloads on cloud, edge, and on-prem to enable 5G use cases like URLLC, EMBB, and MMTC, right? And then we see the AWS regions, local zones, outposts, Snow family address the need of hosting telco workloads on hybrid cloud. And that's what Ashtoush talked about in the beginning. And AWS EKS and EKS Anywhere addresses the needs of running telco workloads on hybrid cloud. AWS Code Pipeline seamlessly provide automation from cloud, edge, and on-prem. And AWS services integrate with ETSI MANO architecture, provide full telco orchestration, including the config that we just talked about. So we're happy that we walk you through all of this. I'll let Ashtoush, you would like to add a few words here?
No, it was great to present you this thing. If you have any questions, you can reach out to me or Vara. We will provide the information, contact information, and thanks a lot.